We work on some additional integrals that yield inverse trigonometric functions. So let us evaluate the integral of dx all over the square root of 2x minus x squared. Take note of the radicand 2x minus x squared. We're going to complete the radicand as a perfect square trinomial. But first, let us factor -1 in the radicand. So negative quantity x squared minus 2x. Recall that x plus a squared is equal to x squared plus 2ax plus a squared. So to complete x squared minus 2x as a perfect square trinomial, we add a squared. 2a is equal to the coefficient of x, which is -2, so a is -1, and consequently a squared is +1. So we shall be adding 1, and at the same time we subtract 1. In order not to change the entire radicand. Our radicand is 2x minus x squared. So if we add 1, we have to subtract -1. Then we write this as dx all over the square root of negative x squared minus 2x plus 1. Negative of -1 is +1. Okay. So let us rewrite this as dx over the square root of 1 minus x squared minus 2x plus 1 is now a perfect square trinomial equal to x plus a, or x minus 1 squared. So our radicand takes the form a squared minus u squared, where a is 1 and u is x minus 1. The differential du is equal to dx. So clearly, the integral is now of the form du all over the square root of a squared minus u squared. And for that integral, it is equal to arc sine of u over a, which is 1, plus c. For our next example, we evaluate the integral of x dx all over the square root of negative x squared plus 6x minus 5. So for this integral, since there is an x term in the numerator which is related to x squared, because if we take the derivative of x squared, that will be 2x, right? So if we are to take the entire radicand as our u, du will be equal to negative 2x plus 6 quantity dx. Let us complete this differential du in the numerator. And to do that, we have to introduce -2. Okay, introducing -2 inside the integral requires multiplying it by its reciprocal, -1/2. So we now have part of the differential negative 2x. But we have to add 6. Since we're adding 6, we have to subtract the same number 6 so as not to change our integrand. Alright? And then quantity dx. The purpose is to complete our du. Negative 2x plus 6 quantity dx. So let us rewrite the denominator, negative x squared plus 6x minus 5. Then we split this into two integrals, negative 1/2 integral of negative 2x plus 6 quantity dx all over the square root of negative x squared plus 6x minus 5. And then this part, negative 1/2 times negative 6 is equivalent to positive 3 quantity, or the integral of dx all over the square root of negative x squared plus 6x minus 5. Okay, so we are splitting this into two integrals. One where we have negative 2x plus 6 quantity dx all over the square root of negative x squared plus 6x minus 5, and negative 6 multiplied by negative 1/2 dx all over the square root of the same radicand. So for the first integral, this now takes the form u to the negative 1/2 du, where your u is negative x squared plus 6x minus 5 raised to negative 1/2. And the quantity negative 2x plus 6 dx is our du. So we apply the power formula. Negative 1/2, u to the negative 1/2 becomes u to the positive 1/2. That will be negative x squared plus 6x minus 5 raised to positive 1/2 all over 1/2. We continue with the second integral, dx over. What we do in the radicand is we complete negative x squared plus 6x as a perfect square trinomial. And to do that, we shall factor first the negative sign. So negative x squared, negative of the quantity x squared minus 6x, and then minus 5. We need to add 1/2 of negative 6 squared, which is positive 9. So 1/2 of negative 6 is negative 3, squared is positive 9. But what we have added actually is negative 9, so we have to add positive 9. This is now equivalent to negative of the quantity x plus a, which is negative 3 squared. Negative 5 and positive 9 is positive 4, or equivalently that is 4 minus x minus 3 squared. So we write it here, 4 minus x minus 3 squared. And we see that the radicand takes the form a squared minus u squared, where a is 2 and u is x minus 3. du is equal to dx. So this now is complete in the form du all over the square root of a squared minus u squared, which is equal to 3 times arcsine of u x minus 3 over a, which is 2 plus c. Now for this part, we cancel 1/2. So we have negative of the square root of negative x squared plus 6x minus 5 plus 3 arcsine of x minus 3 all over 2 plus c. Next, we evaluate the integral of sine 3x dx all over the square root of 5 plus 4 sine squared 3x. Notice that our radicand, in a way, takes the form a squared plus u squared. But there is no such formula yielding an inverse trigonometric function for a radical a squared plus u squared. Okay. At the same time, notice the presence of sine 3x. We know that the derivative of cosine 3x is negative of sine 3x. So what we will do is, in the radicand, we will try to produce a cosine function. And we know that the appropriate identity for that is 1 minus cosine squared 3x. Okay? So we write sine 3x dx all over the square root of, if we are to distribute 4 inside the parentheses, we'll be getting 5 plus 4, or equivalently, that will be 9 minus 4 cosine squared of 3x. So we re-examine our radicand. It is now of the form a squared minus u squared, where a is clearly equal to 3, u is 2 cosine of 3x. Let us take the differential. That will be 2 times the derivative of cosine 3x, which is negative sine 3x, times the derivative of 3x, which is 3, and finally the differential dx. That is equivalent to negative 6 sine of 3x dx. So we shall be needing negative 6 to complete our du, and we multiply it by its reciprocal, negative 1 over 6. So our integrand is now of the form du all over the square root of a squared minus u squared. And we know that this is equal to negative 1 over 6 arcsine of 2 cosine 3x all over 3 plus c.